Okay, again, even though we're not testing, I'm still going to go through the review with you guys. Chapter 11 review. I wish I could call on you guys. I'll make this a little bit easier. So which line or segment is a chord? So remember, a chord is a segment whose endpoints are on the circle. So technically you have two. You could have the chord of IH or HI, the same one. Or remember, a diameter is also considered to be a chord, F, G, or GF. Since it's a segment, remember to put the little line on top, and we're good to go. Okay, which line or segment is the diameter? Remember, the diameter is a chord whose endpoints are on the circle, and it runs through the center. We know the center is E, so it'd be F, G, or GF. Either one is acceptable. Which line or segment is a tangent? So remember, when we talked about tangent, it's where it touches at one point and goes off infinitely on either direction. So JK is considered to be the tangent line. You could have called it KJ, IJ, JI, IK, KI, but this one is a line, so you put the arrows on the outsides. Which line segment is a secant? Remember, secant has that sec at the beginning, which implies it hit twice. Secant lines intersect a circle 2 times. So our secant line would be LM or ML. It hits twice, keeps going. Which segment is the radius? So the radius starts at the center and then goes to the edge of the circle. We have 2 radii. You have EF and EG. Okay, this one is which of the following is the point of tangency? The point of tangency is where the tangent line occurs, and we see that it is at I. So point I is the point of tangency. You could just write I. Either one is okay. Okay, which of the following is the center point? Well, the center point is exactly what it says, the point at the center. So that is E, right in the middle of the circle. So this should be it for the parts of a circle that you have to name. Okay, this takes us way back. It feels like forever to me. So we want to find, or we see that CB is the tangent to circle A. At point B, find the length of the segment AB. So remember, we used the Pythagorean theorem to be able to find our radius. This was early on. So you have to use the A squared plus B squared equals C squared, where C squared has to be our hypotenuse, side opposite of the radius. The other ones don't matter, so you can leave this A squared. You can put this one as 15 squared. We can now substitute in values that we know. Let me do some math. I know 15 squared is going to be 225. I have that one memorized. But I do not have 17 squared memorized. Okay, 289. Okay. Okay, and then we're going to subtract over the 225. That gives me 464. So A squared equals 64. To get our value of A, we got to square root both sides. We get A equals 8 because the 64 is a perfect square. Okay, our next one says, what type of arc is EC? Well, EC here, you see it is not more than half the circle. It's only talked about by 2 letters, so we know this is going to be a minor arc. My pen's bothering me again, so sorry that that's not working well. I feel like this one's a little tricky. So an arc, EB is right here. So if it is under 180 degrees, we call it a minor arc. If it's over 180 degrees, we call it a major arc. But if it's exactly 180 degrees, which is what this one kind of looks like, we call it a semicircle. I'll also take major arc because we didn't really talk about a semicircle. Okay, what type of arc is EDF? E, D, F. That's going to be bigger than 180, so it's a major arc. Okay, this is part 1 of our review. I'm going to pause here, and then we will start again tomorrow. Thanks, guys.